There we go.
It says it's recording.
Yes, it should say that. Okay. All right, guys, for today's lesson, we're going to be looking at the keep, change, flip method of dividing fractions. You've seen this method on Tuesday with Miss York, but I want to do a quick review of it, and then I want to show you something that I found pretty cool that relates to keep, change, flip. All right. All right, so the first thing we're going to do is our do now. I want you to independently answer each question and then type your response in the chat. Please make sure that your response is in a private message to me, Miss Carter, so that everyone doesn't see your answer, okay? Your first question is 1 divided by 1/3. Divide and use the models to help you. Your second question is 1 divided by 1/5. Use your models to help you. Willie, check your first answer again. Good, Willie. Good, Giselle. Matthew. Matthew, check that answer again. I'm going to type you a message. All right, guys, I see answers coming in. Great job. I'm waiting for a few more responses. Ian, good. All right, great. Let's go ahead and go over these responses. So for number 1, our answer here is 3. I'm not sure I can actually draw on here. Hang on. Our answer is 3. And the reason why is when we look at this problem, we see one whole, and that one whole is broken down into 3 separate parts. If I count how many thirds I can put into this one whole, I have 1, 2, 3. So my answer is 3. On the second problem, how many groups of 1/5 do we see inside this whole? Great. 5. Great job, guys. So our answer there is 5. Not too hard, right?
Yeah.
Good. Let's move on to the next one. Let me clear my drawings off the screen. All right, guys. So now we're going to go over the keep, change, flip method. This is the strategy you learned with Miss York on Tuesday. So this is going to serve as a review. We have 9 wholes divided by 4/5. So our first step here is to keep. What are we going to keep here? Someone share out with me. Unmute yourself. What are we going to keep? Which number?
9.
9. Good. So we are going to keep number 9. But what if this was any problem? How could I explain to someone what number to keep?
The first number.
First number. Perfect. So on your notes, I want you guys to write down keep. Always keep the first number. So it doesn't matter if there's a fraction there or if there's a whole number there, you're just always going to keep the first number. All right, the next step in our strategy is change. What are we changing here?
The fraction.
What are we changing?
The division.
The division. What is division going to change to?
Multiplication.
Multiplication.
Good. So underneath it, I have gone ahead and I have changed that division sign to multiplication. Great job. Our last strategy is flip. Willie, what are you thinking? What am I going to have to flip?
4/5.
4/5. And if I flip 4/5, what does it become?
5/4.
5/4. Someone risk take for me. What is that second number called? We talked about it in school, but we haven't since we've been out. What is that second number?
Improper fraction.
It is an improper fraction. Great. But I'm looking for an R word. Flip the
Reciprocal.
reciprocal. Everyone say reciprocal.
Reciprocal.
Reciprocal. We flip the reciprocal. Good. It says flip your reciprocal. That means switch those numbers. Does anyone have any questions so far about this keep, change, flip?
No, ma'am.
No, ma'am. All right, we're going to move on then. All right. So a lot of times you learn math strategies, but you don't learn why we do those math strategies, okay? So I wanted to kind of take a step back and show you why this method works. Why can we keep the first number, change division and multiplication, and then flip the second number? So I want you to watch the entire video. If you have questions while the video is playing, you can put them in the chat, but I promise it'll all make sense by the end of the video. Got it? All right. I'm gonna go ahead and play. Let me make sure you can hear my sound.
Hi, today we'll be dividing fractions. Specifically, our objective is to understand why we invert and multiply to divide fractions and why that works. The question is, why don't we just divide? If we have a simple problem, that actually works well. If we have 3/4 divided by 1/4, we can show that using a model. We have a chocolate bar divided into fourths, and we have 3/4 of that, and we divide into groups of 1/4. We're going to look at how many groups of 1/4 do we have. There's 1, 2, 3 groups of 1/4, so our answer would be 3. 3 groups of 1/4 in 3/4 of a bar. Now, if we have a trickier fractions in our division problem, we run into trouble. For instance, 2/3 divided by 5/8. If we try to show that through a model, we create thirds. It's much more difficult to show 5/8 groups within those 2/3 of the chocolate bar. We get to a lot of division of chocolate that's kind of ugly. So rather than do that, we have a more efficient method, and I'm going to show you why that method actually is division and not multiplication like it seems. We're going to use that same problem, 2/3 divided by 5/8. And the theory here is that we're going to create whole numbers to divide by using common denominators of 1, which is what inverting and multiplying accomplishes. So we're going to have whole numbers to divide.
All right, I'm going to stop it there for a second. What she's pretty much saying is, in order to balance equations, whatever we do to one side of the equation, we must do to the other. Someone risk take for me, unmute yourself. What is a way that I could get rid of this number in the denominator? What are you thinking? How could I get rid of a number in the denominator? What could I do?
Simplify.
Okay, so we're not going to simplify because we want to get rid of that number.
Multiply.
Multiply, good. And if we multiply one side by 3, what do we need to multiply the other side by?
3.
3, because whatever we do to one side of the equation, it must be balanced and we must do it on the other side. All right, I'm gonna let you guys finish watching.
Do this by getting rid of these denominators. If we were to ask ourselves how to get rid of thirds, we would multiply everything by 3 to get rid of that denominator of thirds. So we would want to multiply by 3, and we would also have to multiply our other fraction by 3 to keep it balanced in the equation. So if we multiply this by 3, we actually get 6/3 divided by 15/8. And 6/3 we know is 2 wholes, or 6 divided by 3 makes 2 wholes. So we've just created a whole number there by multiplying everything by 3. We could simplify and do that if you're aware and used to doing that. You can simplify 3/3 actually equals 1, and then multiply that by 2, we get 2 wholes. Anyway, we want to create a whole number over here. So what we're going to do is get rid of that denominator by multiplying everything by 8 again. That includes this side, so our whole number will get bigger. This whole number is going to become a 16. Divided by, and then we have 8 over 8 equals 1 to simplify, which gives us 15 times 1, a whole number. So now we have 16 divided by 15 as our entire problem, which can be written in fraction form, 16 divided by 15. And that's our answer, unless we choose to make a mixed number out of that.
Okay, so what she did was she got rid of the denominators and she made these both whole numbers and then divided them. Remember, our division symbol is actually a fraction bar, and those 2 dots stand for division, right? So she took that 16 and she put it on top of the 15. What type of fraction is this?
A mixed fraction.
It's not a mixed fraction yet. We could turn it to a mixed fraction, but what is it right now?
Improper.
Improper. Good. Good. All right, I'm going to let you finish the video. Now you're going to see her connect it with keep, change, flip, and you'll have your aha moment.
Okay. If we write it in the invert and multiply way, we have 2/3 times, and then you invert the fraction, 8 over 5. Let's show how that relates to this. What we're doing here is multiplying by those denominators, multiplying the numerators by those denominators. Here we have 2 times 8, which is what we achieved here by multiplying that 8 by 2 and getting a 16 whole number. Here we have 3 times 5, which is what we achieved here by multiplying this 3 and having a 15 there. So we are actually cross multiplying to get that common denominator of 1 and get rid of those denominators altogether. So we have 2 times 8 equals 16 over 3 times 5 equals 15, which is a much quicker, more efficient way to complete this problem. Let's do one more sample problem.
Before she does another one, did you guys see how it related to keep, change, flip?
No, it keeps on lagging out.
Oh, the video was lagging?
Yeah.
Did that happen for everybody?
And before the video, the thing that you were talking about, the video was keep pausing.
I was pausing the video.
Like it kept on.
No, I mean, you keep breathing and everything.
Miss Carter. So it kept on glitching out, and before, like the thing that you said before.
Okay, I'm gonna rewind it back and let's see if it'll play without glitching. Everyone go ahead and mute yourself.
By getting rid of these denominators. If we were to ask ourselves how to get rid of thirds, multiply everything by 3 to get rid of that denominator of thirds. So we would want to multiply by 3, and we would also have to multiply our other fraction by 3 to keep it balanced in the equation. So if we multiply this by 3, we actually get 6/3 divided by 15/8. And 6/3 we know is 2 wholes, or 6 divided by 3 makes 2 wholes. So we just created a whole number there by multiplying everything by 3. We could simplify and do that if you're aware and used to doing that. You can simplify 3/3 actually equals 1, and then multiply that by 2, we get 2 wholes. Anyway, we want to create a whole number over here. So what we're going to do is get rid of that denominator by multiplying everything by 8 again. That includes this side, so our whole number will get bigger. This whole number is going to become a 16. Divided by, and then we have 8 over 8 equals 1 to simplify, which gives us 15 times 1, a whole number. So now we have 16 divided by 15 as our entire problem, which can be written in fraction form, 16 divided by 15. And that's our answer, unless we choose to make a mixed number out of that. Okay. If we write it in the invert and multiply way, we have 2/3 times, and then you invert the fraction, 8 over 5. Let's show how that relates to this. What we're doing here is multiplying by those denominators, multiplying the numerators by those denominators. Here we have 2 times 8, which is what we achieved here by multiplying that 8 by 2 and getting a 16 whole number. Here we have 3 times 5, which is what we achieved here by multiplying this 3 and having a 15 there. So we are actually cross-multiplying to get that common denominator of 1 and get rid of those denominators altogether. So we have
How many of you have heard of the butterfly method when we talk about multiplying fractions? Good. This is what the method is. So here they are multiplying 3 and 5 to give them that 15, which is the same thing we accomplished over here. 3 times 5 is going to give us 15, right? You with me so far?
Mm-hmm.
Okay, and then on the other side of the butterfly method, I don't even think I can change can I change the color? This way we did 2 times 8, which is what we did over here, 2 times 8. And 2 times 8 is 16.
Oh, 16. Yeah.
16, yeah, so either way we're going to end up with the same answer, but which method is
Wow.
faster? Which method's just a little faster?
Butterfly.
Yeah, keep change flip, but does it make sense why we do it now?
Butterfly.
Good, stop drawing on my screen, please.
2 times 8 equals 16.
All right, I'm gonna clear all drawings, hang on, and then we are gonna move on to the next slide. Work on checking your understanding. We're gonna do some guided practice. I want you to answer each question. You can answer it on paper and pencil, and then type your response in the chat. I'm gonna put up a 4-minute timer. I want you to do as many problems as you can in 4 minutes, and then we will review 2 of these, okay? I won't tell you which ones we're gonna review now. Just do as many as you can in 4 minutes. Time starts now.
Do we have to, like, are we gonna have to send the problems to you or answer to all these?
Chat, yep, just type your answer in the chat. So you can I'll put a format in the chat. You could put number 1, give me the answer. Then you could put number 2, give me the answer, okay? Just like that. All right, I'm gonna start your 4 minutes now. Good, I see answers starting to come in. Good, Elliot. Good, Audrina, keep going. Audrina, what are you supposed to do with those numbers? Because you're not adding them. You're gonna switch it to multiplication. Remember, keep, change, flip. You gotta flip that second number. Isabel, if you can't see number 3 and 6, just do number 1, 2, 4, and 5. Good.
I have a
Yes, Marcella.
the count if it's a whole number and you can turn it into like 12 twelfths.
Yes, 12 twelfths would equal 1 whole.
Okay.
All right, guys, I'm gonna pause for a second because I see a lot of responses coming in and I'm seeing a misconception. So I wanna go ahead and address that really quickly. Remember, when we talk about keep, change, flip, we're keeping that first number, right? Division changes to what, guys?
Multiplication.
Multiplication, and then what happens to our reciprocal?
It flips.
It flips. So a lot of you are leaving that step out. You're not flipping. So what is my answer here now? What is 2 times 1?
2,
2. And then what is 3 times 1?
3.
3. Good. So our answer to the first one is 2/3. So make sure you are using the keep, change, flip strategy.
Okay, I get it now.
Good. I see more answers coming in. Good. All right, guys, I got about 1 more minute remaining. All right, guys, so I chose 2 of them that we're gonna go over. I wanna focus on number 2 and number 3. Willie, are you doing your work on the back of your newsletter?
No,
Oh, okay. Are you sure?
I'm going.
Oh, okay.
Yeah, I was done.
All right, guys, make sure you have a notebook so you can keep track of it, and you don't want to write it on random paper because you may lose the paper. All right, so we're going to focus on number 2 and number 3. All right, number 2 says 2/3 divided by 4. Someone help me out. What's my first step?
Add a 1 under the 4.
Add a 1 under the 4. Great job. You can put a 1 under any number, and it'll still be a whole number. What's my next step? Someone else.
Keep the 2/3. Change the multiplication. Change the division multiplication.
Okay, so I heard my first step was to keep the first number. What's my second step?
Change the division symbol to a multiplication symbol.
Okay, and then what are we doing with the second number?
Flip it.
Flip it. Good, I'm gonna draw an arrow. That's kind of an arrow. All right. So let's go ahead and write this out. We have 2/3 times 1/4. What is my answer here, everyone?
2
2 over 12. Good. Can I leave this fraction the way it is?
No.
No, what do we notice about the numerator and the denominator here?
They're both even.
They're both even, so if they're both even, that means they're both divisible by what?
2.
2. Good. Let's go ahead and divide our numerator and denominator by 2. What is 2 divided by 2?
1.
4.
1.
Divided by
1.
1. And what is 12 divided by 2?
6.
6. Good. So our answer there is 1/6. Great job. Our second problem we're going to cover is 6 divided by 3/8. So now our whole number is first. All right, help me out. What do I do first here?
Put 6.
Put a 1 under the 6. Good. Hang on.
Can you hear me?
And then I am doing what to this first number? Keeping it. What do I do to my second number?
Change it.
To what?
Multiplication.
Good. And then my third number, what's happening? Second number, I'm sorry.
Flipping it.
Flipping it. Cool. All right, that's an arrow. All right, so I end up with over 1 times 8/3. Someone who's quick with their math, what is 6 times 8?
48. 48.
48, good. And what is 3 times 1?
30.
3. Can I divide the numerator and denominator by the same thing?
Yes.
Okay, can I divide my numerator by my denominator?
Is it me or
How many groups of 3 can I make from the number 48? How many groups of 3 can I make from the number 48?
12. Hold on.
I can't hear. Someone said. All right, guys, let's count by 3s till we get
2.
48.
2.
2 wouldn't make sense. Let's go ahead and count by 3s till we get to 48. Everyone do it with me. 3,
6.
6,
9.
9,
12.
12,
6.
16. Mrs. 16.
Willie, since you want to risk take, count by 3s till you get to 48 out loud for everyone, please.
Why?
Because they need to hear it.
Okay. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48.
Cool. So Willie got 16. Did you all agree with him? Willie, I do appreciate it. Great job. I really do appreciate that. Thank you. All right. Now the last problem is a challenge problem, okay? It is a little bit hard, but I have faith that you guys can do it, okay? Oh, it didn't erase my, hang on. Oh, clear our drawings. Cool. So your next problem is 1 7/8 divided by 1 1/4. I'm going to help you out with the first part here. How do I change 1 7/8 to an improper fraction?
Times and then plus. I can't so.
I'm going to rewrite it, Elliot, down here. 1 7/8 divided by
8 with the 1 and then plus 8 with 7.
all right. So I hear someone saying, I think it's Matthew and Willie, we multiply the denominator and the whole number. What is 8 times 1, everybody?
8.
8 plus 7?
15.
Good, so we have 15/8. How do I change the second fraction?
15. Make it to an improper fraction.
Good, so we need to do the the denominator times the whole number plus the numerator. 4 times 1, everybody?
4.
1.
Plus 1.
2.
5, so we have 5/4. So now I want you to use your keep, change, flip method and solve this problem. I'll give you 2 minutes, okay?
Four. 5. Cool. Wow.
All right, guys, someone help me out. What is 15 times 5? Sorry, no, we didn't flip it. I'm sorry. Division changes to
multiplication.
And then we flip our reciprocal. All right, so my problem is 15/8 times what?
4/5.
4/5. Good. What is 15 times 4?
60.
Times? Did someone say 16?
60.
60. Okay, good. 60.
60.
And what is 8 times 5?
40.
40. Can I leave this the way it is?
No. Divided by
How many groups of 40 can I make out of number 60?
1.
1, and how much would I have left?
20.
Out of?
40.
Can I leave this way?
No. No. 1/2.
What does 20 out of 40 simplify to?
1/2.
1/2. Good, because 20 is half of 40.
Divide.
Great job, guys. So the last thing we're going to do today is go over some announcements.
Time.
Your announcements for today. Page 99 is due Monday. And each week, you need to have 100 minutes on exact
Super
path by
glitching.
Wednesday. What'd you say? Okay, so you need to get page 99 sent to me and Miss York by Monday. And you need to have 100 minutes completed on exact path math by Wednesday.